Welcome to this video tutorial on graphing simultaneous linear equations. You first met the idea of linear equations back in year 10, and we've been exposed to a variety of techniques to solve simultaneous linear equations, such as graphical techniques and algebraic techniques such as substitution or elimination. What I've got here is a couple of equations mapped out by these two lines, y equals mx plus c, where currently m is 1 and c is 1, and the blue line, which is mapped out by nx plus k. Currently we have values of n of 2.3 and a y-intercept there of minus 1.5. Now these sliders in the Desmos.com website, which is a fantastic website for illustrating these concepts, allow me to change the gradient of a line and also change its y-intercept. So as we do that, you can see the intersection point of those two lines will change, and we'll have a different solution because we have two different linear equations to solve. We do, however, have special cases of linear equations where we may not get a single solution. As you can see here, these two lines cross at a single point, so there is one individual solution, what we call a unique solution. However, if I change the gradient of this blue line and match it up with the gradient of the red line, you can see both the gradients are now at 1, rise over run of 1, and they look like a pair of railway tracks. They are in fact parallel lines, and parallel lines will never meet. So if they never meet, we don't have an intersection point, and therefore we don't have a solution to those two linear equations. So the current equations we have are y equals 1x plus 1, and this second equation of y equals 1x minus 1.3. And if you tried to solve those on your CAS calculator, there'd be no solution found because we have no intersection points. We can now alter the y-intercept of this second graph, and we can move those lines further apart based on this vertical translation and moving the y-intercept, and we can move that line up to a certain point where in fact we cross over, and if we just pause there with a k value of 1 on that second line, you'll see that both the red line and the blue line are now one and the same. They do in fact have the same equation, 1x plus 1, and they are in fact what's called coincident lines. So when we have the same gradient and we have the same y-intercept, we will have what's called coincident lines, and therefore we will have an infinite set of solutions. So when you're trying to solve these equations, you're really asking yourself where or what is the coordinates where the blue line and the red line meet. Now when the lines are coincident, as in one and the same, there's obviously an infinite amount of points that satisfy that particular question. So we have an infinite number of solutions. If we go back to our first case where we've pulled these lines apart, now we have the same gradients. So m1 and m2, the gradients of our two lines are the same, but we have different y-intercepts. So if that's the case, if m1 and m2 are the same, but the y-intercepts are different, then we have the special case where we have parallel lines and we have no solutions. So what the questions are going to be like when you're meeting these particular concepts are to play around with these values of m and c and try and get these three situations: unique solutions, no solutions, and coincident lines or infinite sets of solutions based around this as a particular concept. Okay, we'll leave it there and we'll hit some exam questions next up.